It's now time for us to build a front end using TypeScript. We will build it for the backend application we built in the last lecture. If you didn't follow it, you might just use it and execute it with npm run dev. Well, we will also practice TypeScript using React in this section. Why React? Because again, React is still, at least at the time I'm recording this, the most popular UI frameworks for JavaScript, and also it works great with TypeScript. Well, what you can expect from this section, we will see first of all how we can initialize a React TypeScript project. We will do this with Vite. We will also have a small recap about React components, state, properties. We will get familiar with React types, basically what TypeScript brings new to the table for React. We will see then some more complex topics like rendering lists, like handling dynamic data, and in the end we will see how we can connect to a backend, the backend that we built in the last section. Well, again, some big requirements and a big disclaimer. As a requirement for this section, you have already need at least a basic React knowledge. This means that if this is the first contact with React for you, please first take a simple YouTube tutorial, because I won't specify all the basics inside this part of the section. Of course, this is not a React tutorial, this is simply a practice session for our course, and of course for me it's impossible to present everything about React in 1 hour. As I said, this is not a React tutorial, but simply a practice session. Let's now move to the workspace and see exactly what we will build inside this section. This is how our workspace will look like, this section 13. We will have some basic components. We will put them together into one very basic application. Let's see it inside the browser, a dump application, in which we will just have a simple form, in which we will add employees. We will give them a name, a position, a salary. And then we can simply add them, and when we click add employee, this employee is also added inside a list inside our browser, but also this employee goes to the backend. So at this point, if I will refresh this page, you will see now that this Marco employee that I just added is now persisted to the backend. So we will see how we can access the backend inside this section. This being said, again, if you're not into front-end development, or if you're not into React, you might simply skip this session. For the moment, let's start to initialize a React TypeScript project in the next lecture. Let's first create a React TypeScript project, and as we are speaking, there are multiple ways in which we can do this. The most complicated way would be from scratch to initialize an npm project, then install React, and also then configure Webpack or ESLint or any other kind of bundler, which is a really complicated task. Another solution would be to use different tools. Until recently, we had Create React App, which was deprecated for a good reason, and now we have other tools that helps us initialize a React project. Currently, the React documentation has steps for initializing a project for different other frameworks like Next, like Remix, like Gatsby, like Expo, and other frameworks. But these kind of frameworks also require a learning curve by themselves. So for this part of this course, I choose to use Vite as a initializer tool for a React project. This Vite is also a very popular choice for beginner project. So let's use Vite to initialize a React TypeScript project. I've been doing this inside the course resources. You can do it on a separate folder inside your computer. So what I will call npm init, I will call Vite at latest. Very careful for typos. And with the template React -ts, which stands for TypeScript, of course. I will click enter, And I will give a project name. I will call this section 13 because this is the current section of this course. You may give it whatever name you like, and basically we are done. And with all it did is initialize a new project inside our computer. I will cd in this new folder, and here I will call npm install. Alright, npm install is done. Let's quickly explore this project. We have everything we need right here, at least as a starter project. If we look at the package.json file, we will see that as dependencies we have React and React DOM, and as dev dependencies we have all kinds of dependencies like TypeScript, like Vite, like dependencies for linting. In the next section we will also talk about linting, and of course we need the types that we require. Just as a side information, if we look at what Vite contains, let me open the package. If we look at what Vite contains, and I will check its package.json, you will see that under the hood, if I look at its dependencies, it uses esbuild and rollup, and these are solutions for bundling. This is just as a side information. Well, let's explore further this project. We have a package.json file, we have a tsconfig file. At this point we know, or we have a good idea about what this TypeScript config file should look like. Things are pretty new inside this configuration. One new thing is this module resolution, which is a bundler. We are also strict, and we have this JSX set to React JSX. Of course we need to have this configured if we need JSX, and of course for React we need it. One last point, let's explore the source file, and the source file has simply some components, and what we can do is simply run this file right here. If I will look at the package.json file, in order to run it, we need to call dev, and let's simply run dev to see if everything works. So here I'll say npm run dev, and let's open this sample application. And this is the very simple application that Vite gives us. I have a counter right here just to remember how React works. Let's also, talking about remembering, let's proceed into the next lecture and remember, have a quick remembering about how React properties and state work. Let's first see from a high level how React works under the hood. We will talk about state, props and components, and if you are already familiar with these concepts, maybe you are experienced in React, you might just simply skip this lecture. Well, React components can have properties or state. Properties come from outside the React component. State is belonging inside the React component, just as I drawed in this very great presentation which I've made. The key feature of React is the way it reacts or re-renders a component the moment its state or properties change. Well, this is the main selling point or the main feature of React. If you understand this, you understand a great way in which React works. Also, React components can be of two types. Can be parent components or child component. A parent component can have multiple child components, and so on. Well, and the parent components can inject their properties or their state inside child components, which on their own can have state or properties. And to understand better how parent-child components and how state prop and prop works, let's see a quick example. You don't have to type it, let's just analyze it and then see how it works. So let's switch to the workspace. Well, we are in our workspace and I've put all this code inside reminder.tsx inside the components folder for the course resources. Basically, this file has two components, a parent component and a child component. Each of them has a simple counter, which and the button, we press the button and the counter increments. Simple as that. The only difference, or the only key point right here, is that the child component receives also some properties with the parent counter, and the child component is responsible for rendering both the child counter and the parent counter. This is the way this is working. And in the end, we are simply adding this parent component to the app main component, and I will just render this component inside our main file. Well, because we will be working with logs, I want to show you something. Inside the main.tsx, I've commented out this React strict mode, because if we have this, then we will see double logs or double console logs, so I don't want to see this. I just commented this out for a basic example. There's no problem. Let's start this application with npm run dev. You don't have to do this, just observe what I'm doing. And let's open this inside the browser, and also let's open the console. So I will call the inspect, and let's see the console. Well, this is our very basic implementation right here. We see a border for the parent component, the one with blue, and a border for the child component, the one with red. The first time these components are loaded, I will refresh, you'll see two logs. The log stating that the parent component is rendered, and also the log stating that the child component is rendered. Of course, we are opening the application and everything renders as we expect. Well, what happens if I increment the child component? Every time I increment it, we will see a log right here inside the console. Very nice. But what will happen when I will increment the parent component? What logs we will see? Take a break and think about it. Well, let's see what is happening. We will see both logs or not. Let's see. And as you can see, as soon as I'm pressing this button, both components will be re-rendered. Also the parent component, but also the child component. The parent component is re-rendered because it has its own state changed, and the child component is re-rendered because it has its properties changed. And I hope with this basic example you had an understanding, or a basic understanding at least, about how parent, child, state and properties work inside React. If you understand this, you understand a important part of React. Let's proceed into the next lecture and talk about the React with TypeScript specific types. Let's now see some basic types for React, properties and state, and also how we can add types to our very basic components. Let's look at this very basic sample.tsx file. You know, when I'm starting a new React project and I see that this TSX code doesn't work, I wonder why, and then I remember that I named my file .ts, not the .tsx, you know, a stupid mistake. So in order to write TSX or JSX code inside your file, make sure that you use the right extension. Now, how we can annotate with types our properties? On the screen we see three ways. I see three components, and at line 6 right here we have the most basic way in which we can write a component with a simple arrow function. And as you can see, here we are passing a message as properties, which is of type this sample props, which I've saved outside. This is a type. We can as well use an interface, whatever you prefer. I see there's a lot of debate between some developers, but in the end they do the same thing. Use interfaces or types as type annotations, you know, whatever you like. What I want to emphasize right here is are the two ways in which we can pass properties. This is by using this structuring syntax. Then inside the component we will directly be able to access the property. I really like the other way in which we can pass components by directly annotating the whole properties of the component with these props and sample props. The reason I like this approach more is because in big complicated components I know exactly if a constant is a property or something else. If this constant is related or it's tied to the properties, then I know exactly that it comes from outside. And there's a third way, this more verbose way, which again I prefer it, because this is the most clear way. Even if all of them do the exact same thing, this is the more clear or the most clear way in which we can write our components with these type annotations. Well, there's also some discussion about how we can write our generic functions. If, for example, you will have a generic function inside your .tsx file, like for example, I have it right here. I have this export function, generic function with t and the argument of type t, nothing new here. Well, what can be a little annoying can be if you are trying to use the arrow syntax. For example, if you will want to write the same generic function, but this time as an arrow function, again a generic function, then the TypeScript compiler, or better said the transpiler, won't know exactly what is happening right here, because React will or the compiler will think that this is JSX code. Well, there are two solutions to this. One would be to just add a comma right here and then everything is clear to the compiler, or you can simply say right here extends unknown. Again, this can be a solution, but I find the comma much more easy to understand. You will see from time to time this syntax when you will work with generics inside .tsx files. And talking also about types, let's talk also about the types for component state. Let's see a simple example. In this function sample4, I'm using the useState hook. This is the most popular hook for React, and it does exactly what its name suggests. It handles the state inside a component. Well, let me import it. So I will import this used state from React, and now let's analyze this very simple line right here, line 29. But if you understand this, then you will understand React with TypeScript. Well, we are using this useState function, and if I will try to look at its component, you will see that it has inferred the type from what exactly we are passing right here. If I will use this useState without any input, then the compiler will complain that this is undefined or any. If I will pass a string right here, then count will be string. If I will pass a number right here, then count will be a number. You will see that also this is explicitly annotated right here, number. Or if this state can be undefined, you can pass right here undefined, but this will mean other problems inside your compiler. Well, you need to understand that with this useState you pass a initial value to this state of the component, and the type will be inferred from that initial value. If the type of the initial value is number, then the type of the state will be number. Also, this setCount will accept only numbers, of course. If this is a number, then this setCount function will accept only numbers, as we are seeing right here. Well, we had an introduction to the types of React components, properties, and state. Let's proceed to the next lecture and start to write a real application. Before diving into writing components, let's take a few minutes and think about what is the objective of our simple, basic, dumb application, and what would be the best way to achieve what we want in the simplest way. Well, we simply want a dynamic list inside our very basic application, a list of employees. And the sources for that list will be in two places. the most important place or the first source is a outside service, a data service. Let's say from the internet we are accessing a server from our front-end application, which simply sends us back a list of employees, and we will simply display that list on the screen. The other source of data for this list would be a simple form in which we are creating an employee using a React form. If everything is alright, we will send that data to the backend, but we will also want to add that data inside our list. Well, as I said, a very basic application, but making it work in the most simple way possible is not an easy challenge, and I've created before recording this lecture multiple versions of this application, and I will present you in this lecture the most simple one in my opinion. Well, what we want to show inside our application. We will want to have a main component, an employee component, which will have a state which will be a list of employees. Simple as that. Well, inside this parent component, we will have two other smaller components, and each component will have its own very specific purpose. For example, we will have a component which will hold the employee form, the add employee form, and another component which will have only the mission to display the list of employees which are held by the main employees component. Well, pretty straightforward, but how we can achieve this? How we can give it a dynamic behavior? Because we want, as soon as we will add employees with the form, we want this list to be updated. Well, how we can do this? Pretty easy. We will use this employee list component to render this state of employees, and then this add employee form component will call a function which will also belong to the employees component, will call a function on employee add or any name you like, which will simply add or modify this list. And as soon as this list will modify, since will be a state and a properties of this employee list component, it will re-render this component and our list will be dynamic. Well, this is the very basic architecture of our dump application. Let's proceed into the next lecture and start writing our employee list component. Finally, we can start to implement our dump application. The first step would be to think about the model of our data. And because I'm lazy and we already talked about models inside this course, I will simply steal the model from other part of our application, talking about the backend application. If you missed this part of the course, no problem, it is very simple. Well, let's think about where was the data. Right here. Inside this model, we have this very basic employee model.ts file. I will just steal this file, copy, and paste inside our source. And here I will create a new folder. I'll call this model. Different ways in which we can arrange our data. There's no one solution right here. For this project, I will simply add a file inside a model folder, and I know that this model folder contains the way our data is shaped. And since we will be creating data or employees with this form, I will simply make this ID and employed at fields optional, because yes, this will be generated by the backend. From the front end, we will only provide a name, a position, and a salary. Well, now that we know how our data will look like, let's create a new component, and as before I stated, I like to put my components inside a components folder, and I know that this folder only contains components. And since we are talking about employees, again I will create a new folder which will only hold components regarding employees. And here I will create a new file, finally our employees.tsx. Alright. And the first thing we need to do, return a function. So here I'll say export function employees. Alright, this is our main component. What is the state of our component? If you remember the last lecture, we said that we will have a list of components. So here I will say we have a state with employees and set employees, which will be a list of employee like this, and we initialize it as an empty array. And what we want right here, let's just return our JSX code. Let's put everything inside a div right here, and with this JSX code, here we will put our two other components. As I said, we will first start with the list, so I will create a new list component inside our employee folder. So new file right here, employees list tsx right here. And I have already put the code right here because the time is of the essence. Our list is a simple list which receives a list of employees as properties inside this component. The interesting thing inside this dump example is just the way we are rendering a list inside React. Of course, there are multiple ways in which we can do this. A cool way would be by using the map function from JavaScript arrays. Here we are iterating through each employee and we are returning a table row containing the employee name, this is the key, the employee name, the employee name right here, and the employee salary. So we will have a table row containing the name and the salary, because yes, salaries are very important, or not. In the end, we simply are putting inside the table body right here our rendered employees. Alright, let's save this. You can take this from the course resources as always. There's no point of typing after me. Well, let's now use this employees list inside our employees component. Right here, let's simply render this component. So here I'll say employees list, and this employees list requires a list of employees, and our list of employees is our employees. Right here. All we need to do right now is populate it with the initial values. And for this I will create yet another file inside yet another folder, because I will have a folder containing different services that are used inside our application. So here I will create a new folder, call this services. And let's create a data service, and because this will be a dummy service, I will call it fake data service. So here I will say fake data service .ts, and this data service will simulate that we are calling a server outside our application. After a few lectures, we will also write a real implementation for this data service. For the moment, let's write right here some dummy data. And this is our very simple implementation of our data service, a simple getEmployees function, which returns a promise, because in the end this will be an asynchronous function, which simply returns a list of generated employees. Let's now use this getEmployees function inside our main employees component, and the important question that rises is how we can call this initial function as soon as this component is rendered, and only call it once. Well, we can do this very simple by using another hook from React, not the useState hook, but the useEffect hook, which we'll be using in order to call a function as soon as the component is rendered. So inside this useEffect hook, I will call it. Well, this is the way we can use effect, and it looks a little strange because we are working with asynchronous data. Basically, what we are doing right here is to put this getEmployees data inside an asynchronous function, and then we are simply executing this function. Very important, never forget to call this secondary argument inside this useEffect hook. If we wouldn't call this, we would leave it like this. This useEffect hook will be called every time you are rendering this component, and if this function right here triggers a rendering of our component, then this will be called indefinitely and will cause your browser to freeze. Yes, I also did it once with an AWS backend service, and it was always executing the service. I lost a few cents. No problem there. Well, this is basically our application. Let's see if this is working. Let's call this main employees component inside our app.tsx. Right here, let's get rid of everything. Let's clean everything right here. Start fresh. And what we really want right here is just to render our employees component right here. Format this a little, and basically we are done. Let's try to see if everything works. npm run dev. And let's see if our list is populated. And yes, we have an initial state of our list. As you can see, we have a simple table with the name and the salary. Let's make things dynamic, and let's build a form that creates new employees inside the next lecture. We have our employees list. Now we can implement our employees form, which will add new elements to that list and also send them to the backend. Well, for this, inside our employees components right here, let's create a new file and call it employees form. And I've paused the video and put the implementation, and let's see what exactly is happening inside this React form. Well, basically this is just a simple React form, but I will also explain it as a part of this lecture. Well, the most interesting thing about this React form is that it has a property which is a callback function. So when this component is created, it will receive from outside, from its parent component, a function called onEmployeeAdd. And here inside the interface, I've only put the signature of the function in order for us to retain our types. So we have this onEmployeeAdd, which receives an argument of type employee and returns back the ID of our employees. Well, let's now see the state of our employee form. We have three fields: a name, a position, and a salary. And as you can see, the salary is a number, the others are strings with their initial values of empty strings and 0. The handle submit will be the action that will be called when we press the submit button. And as you see, usually the events inside React will be of type synthetic event, and usually the first thing we do is to prevent the default of the event in order for us to be able to proceed nicely inside our function. If all three elements inside the form are completed, then we are creating here a new employee and we are sending it to the server with this onEmployeeAdd callback function. Basically, this is where the magic will happen. Let's say like this. If everything is alright, we will simply log down the employee of the ID of our employee. And now let's look also at the JSX code right here. We have a form with this onSubmit action, and then we have three labels: name, position, and salary, and then the button which will call the onSubmit action as we press it. Basically, this is it. This is the way we can implement a React form. You can Google it if you want to know more about React forms. Of course, they are much more complex than this. This is just a basic example. Let's save this and let's use this inside our employees main component. So right here, let's add a new entry and call this employees form right here. And this employees form will receive or will require an action of type onEmployeeAdd. So let's build this function right here. All right, I have pasted this function right here. This is our function. Will be an asynchronous function, and it will, inside its implementation, will simply call this create employee. I will implement this function inside the data service because this is the place where we will call the outside service. Just as we are getting an employee, we will call the create employee from our service. So inside our fake data service, I will implement this create employee function like this. This is our function right here, create employee. On the next lecture we will write real implementation to these functions, and now let's use this function right here. Alright, and now we can simply call on employee add inside our employee form. Right here we need to specify on employee function on employee. Alright, and basically we are done. Let's save everything and let's try to start our application. Now we have a very nice looking form. Let's give it a name. The position will be engineer or HR. And what I want to show you when we are creating this, I have inside our employee form, I have skipped type checking for this the position. This is a completely different discussion. Maybe we can do it inside another implementation. Just to keep things going fast, I've skipped type checking for this. Alright, let's see our form if everything works. And let's have it a salary right here, and let's add this employee. And as you can see, now our list is updated dynamically. Inside the list we have a new entry, the one that we just put right here. Of course, all these actions are happening locally. Let's build ourselves a real implementation of our service, which will access the backend implementation which we built in the last section of our course. If you didn't follow with it, you can just start the project. It will be available as a resource for you. And the last point before finishing this lecture, inside the employee component, our main employee component, after we get a new employee right here, we will call the set employees, and this is the way we can update a array in React and JavaScript by using the spread operator and basically creating a new array which also contains the newly created argument. Well, let's now write a real access to an outside service inside the next lecture. Let's stop using this fake manually written data from our data service, and let's write a real implementation that accesses a real server. And we will access the server from section 12. If you followed along, you might use your own implementation. If you didn't follow it, just use the course resources. But first, until then, let's quickly write our real implementation. So I will just copy and paste this file, and I will rename it to data service without fake. Alright, let me delete everything right here and start fresh. So we have two functions, one for creating employees and one for getting employees. First of all, what we will need a connection or a direction to a URL, to a server. So we will need a server URL. I will save this upstairs. So here I will say const URL is, and I will put, maybe leave it for the moment. We will leave this later on. What we want is to use the fetch request from natively inside the browsers, and lately also this is implemented in Node.js. So here I'll say const result is await, and we will use the fetch method, which receives two arguments, a URL and some options. Let's fetch this URL and then also pass some options right here. What we want to do when we are creating an employee, we want the method to be post. We want to say that we are posting application JSON content, so we need to put a header with a content type of application JSON, and then we need to send the body as a stringified version of our employee. Well, if everything is alright, I will say right here const JSON result is await our result, and we need to take this result and parse whatever it is inside it to JSON to have something that our browser can understand. And this is a little limitation of currently of the fetch function inside the browsers. For Node.js, I think we have generics, so we can pass a type as a generic right here, but since we don't have this, we will just do this manually. So I will use a simple as cast, and the server will send us, if everything is alright, a response with an ID. So with an ID of type string. And now we can simply return our JSON result ID. This is what usually our application expects. And the same thing we can do it with the other request. Very little differences right here. Instead of making a post request, we will make a get request. We are not sending anything inside the body right here, and we will simply return the JSON result like this and like this. And here inside this method we have types. So because we put it right here, a promise of type employee array, this JSON result is usually of type any. So when we will use this function inside our code base, we will have types because we put them inside the function signature. Well, let's test this implementation and see if it works. Yeah, before testing it, we need a reference to our URL, and our URL is this one right here. The requests. This is the one, localhost 3000. This will be the place where our server will start, /employees. This is the one. Alright, and basically we should be done. Let's use this inside our employees right here. So instead of making imports, this create employee and get employees from our fake data service, let's import them from our real data service. Alright, let's start our server and see if everything works. The server that we built in the last section. So I will start a terminal inside section 12 for me. And here I can run npm run dev to start our server. Alright, and now let's start also our UI. So let's create a new terminal, cd our section 13, npm run dev. Alright, let's see if everything works. I will open this inside a browser. And as you can see, currently we don't have any employees. Let's inspect the console and see if there are any errors or not. If you have a little experience with working on backend applications or server or also frontend applications, you might expect an error that comes along when you try to link a frontend to a backend. Let's see the error. It is a very nasty error, but the solution will be quite simple. So if I will inspect the errors from this entry right here, you will see all kinds of errors right here, which are coarse errors. Well, usually our server works just fine, but if we want to access data from a server from inside a web browser, web browsers have this special protocol or special convention for security reasons to also search for coarse headers. So all we need to do inside our backend, so to fix this error, we can't fix it from the front end, we need to fix this from the backend. If you're using this server as the resource, with this error will be already fixed, but if you are using your own server, let's fix it together. Well, all we need to do is to add this access control allow origin header inside our responses. Let's do this. So in our section 12, our server right here, let's make this small right here, we need to add inside our Express server, inside all our requests, we need to add a allow control access origin header. And if you will Google Express and add course header, you will see there's also a package for course, but since the solution is only 3 lines long, I will just manually write this implementation. So this is the solution to the course problem. We simply need to add a header to our response from inside our server with this content: access control allow origin, and also another header with access control allow headers. And this is the dynamic important part. If you don't know exactly where your website will live, or you just want to continue with your implementation and take care about this course problem later, you can simply put a star right here. For the moment, we know that we will access this data from this address right here, the one that will be served by our Vite server. If you have another address right here, put it right here. Well, let's save this and let's see if the server is reloaded. Yes, the server started once again. Let's try now to make the same request. Let me clear this console right here and let's refresh this page. Alright, and we don't see this error anymore. This means that we are ready to create elements inside our application. Let's see, let's give it a name. Mary, let's say that this is HR, and let's give it a salary. Alright, big salary. Let's add this employee. And yes, our employee was added. Well, this is nothing new until now, but what happens when I will refresh the page? And remember, when I will refresh the page, this data should be persisted. Let's see. Yes, if I refresh the page, as you can see, our front-end application will go to the backend and will make an interrogation for employees. And as you can see, this is persisted on backend side. Well, this means that our application works. What's still left to do is a little error handling. For example, if we are passing an invalid position, we are not making any validation inside our front end. But let's say that we are doing like this. There's a little inconsistency right here. If we inspect this, you will see that we should get an error right here. If we add this employee, we are not getting any error, but we should get an error from our server that something is wrong. Let's implement this inside the next lecture. Our small application has still a lot of polishing. For example, one problem which we also saw in the last lecture, here we are proceeding. If we are creating an invalid employee from our front end and we try to add it, in the console we will see an error, and because we are not having the right data for the position, but also we are adding it right here locally, so things are inconsistent. Let's fix this inside this lecture. Let's add some basic error handling to our code from the front-end part. Well, what we could do, the error appears when we are trying to create an invalid employee. Let's see what happens. So here at line 6 we were getting a result from the fetch request. We can do things based on this result. For example, this result has a field. I will make a check if our result, and this result has a field called OK. Well, if things are okay, we can do things, but here we can make the check. If things are not okay, we can try to throw new errors. So right here I will say, if things are not okay, here I will say const. For example, before seeing what we get, let's just print out the result. So here I'll say console log JSON result. Alright, and let's see how the things are looking before actually building a error. If I will try to add an employee, you will see that we are getting a message from the browser, from the server. This is what we implemented in the last section. We are receiving an array which has an element, which has a message field, which has our value, our error that we need to show to the user, or maybe to whoever consumes our backend. So In this lecture we will see how we can take this error and print it inside our application. First of all, we need to go inside this object and reach this message entry. As you can see, this is an array with one element. So here I will say const message is our JSON result, and in order to use types I will remove this type annotation right here as an array. Let's get the first element, and here I will access the field message. If you remember, this is the one, message dot message, and let's now throw new error with this message. Throw new error with this message. Alright, and now we have an error from our data service. Let's handle it inside our main employees. Well, and let's say that we want, when we are having an error inside our request, we want to show a message inside the view of our application. Let's do this. For this we will need a new constant to hold our state, so I will copy and paste this, and this will be error message right here, and let's call the method that is setting this set error message. We don't need any right here, let's just make it initially a simple string. Alright, now things are happening inside this onEmployee add. This is where the things are going wrong. So let me delete this log and wrap this inside a try catch. Try catch, format this, put our logic inside a try catch, and in case we have an error, as you can see, this is error of type unknown. I don't know why TypeScript made this decision. What else can you throw in JavaScript or TypeScript besides errors? Maybe you can throw something else, I really don't know. But we need to add a new line of code right here. If error, instance of error, otherwise we will have an error right here, error handled while handling error. If we have an error, why we are trying to do this, let's just say set our error message to our error.message. And basically we are done with handling the error. Now we also need to show it in case it exists. So when we are first trying to load this all-employee add, let's just clear this error. So here I'll say set error message with an empty string. First of all, clear the error on a new try. Now all we need to do is dynamically show this error message inside our JSX code in case it exists. Well, we can do this fairly simple by using the ternary operator inside the JavaScript. Right here, let me make some room. Basically, what we are doing right here, we are inserting a place in which we are putting code, and this error message is a string which can be empty. If this string is empty, then we will show nothing, or we will return null from this code block right here. Otherwise, if this error message is not null, then we will return a label which will be red, to jump inside the eyes, and with this error message. Let's see if this implementation works. Let me save this and let's now see our implementation. Well, let's give it a wrong name, a wrong position, and a salary, and let's try to add our employee right now. You'll see now we are receiving the error message inside the screen. We will get invalid enum value. If you remember from the previous section, this is a Zod validation error. We could also use Zod inside React. Maybe this is a topic for another lecture. But as you can see, what I wanted to show you inside this lecture, that sometimes we can take the errors from our backend, and if they are relevant to the user, we can print them dynamically inside the UI. If we are passing a write data, maybe add right here and with HR, if you are passing a write data, the error message should disappear and the data should be added right here. Mary 2, for example. Yes, the error message disappeared and our element was added to our array. Basically, this was all our application. We only scratched the surface of React, but what I wanted to show you is how to use it, or how to have a practice session with TypeScript.